tan x equals root 3 and cosec x equals minus 2. Now let us look at these one by one. Because tan x is positive under root of 3, therefore from the unit circle concept we can guess that x must be in quadrant 1 or quadrant 3, because these are the quadrants where tan x is positive. Now principal solution contains the value of x which are in the range from 0 to 2 pi. Therefore, if we can find a value of x that is in the first quadrant, then we can easily find the other value of x which is in the third quadrant by expressing it as pi plus x, because we know that tan of pi plus x is tan x, which is same as saying that if x is acute, that is it is in the first quadrant, and tan x is positive, then so is tan pi plus x. And now let us therefore write the principal solution for question 1. Principal solution PS. Now we already know that for tan x equal to under root 3, one possible solution in the first quadrant is x equals pi by 3, which is 60 degrees. And therefore the other solution which is in the third quadrant would be pi plus pi by 3, that is 4 pi by 3. And those are the only two possible solutions, because as we have seen, tan can be positive only in two of the quadrants. And to find the general solution, GS, for the first problem, we express tan x as equal to tan of pi by 3, because we know that pi by 3 is one of the solutions. And the solution to this equation, tan x equals tan pi by 3, we already know is that x equals n times pi plus pi by 3, where n belongs to the set of integers. So the trick to finding the general solution is to first express the general trigonometric function, for example in this case tan x, as equal to a particular value, for example tan y, which in this case is tan of pi by 3, one of the solutions that we already know. And then we write the solution to this equation as the general solution. Now let us look at the second part of this problem. Cosec x equals minus 2, which we can write in terms of the more popular function, that is sin x, which is inverse of cosec x, being equal to minus 1 by 2. So the solution to equation cosec x equals minus 2 is the same as the solution to the equation sin x equals minus 1 by 2. And we know that sin x becomes negative in either the third quadrant or the fourth quadrant. Therefore, if we know an angle y for which sin y is plus 1 by 2, if we know a y that is acute for which sin y is 1 by 2, then we can find x as either pi plus y, that would be in the third quadrant, or 2 pi minus y, which would be in the fourth quadrant. And we know that sin of pi plus y would be minus sin y, and sin of 2 pi minus y would be also minus sin y. Now we already know that if sin y is equal to 1 by 2, one possible value of y in the first quadrant is pi by 6, that is 30 degrees, and therefore the principal solution for x would be pi plus pi by 6 or 2 pi minus pi by 6, which is 7 pi by 6 or 11 pi by 6. Those are the two principal solutions. And as for the general solution, we now express sine of x as equal to the sine of a particular angle, and we know that one such angle is 7 pi by 6. So we'll write sine x equals sine 7 pi by 6, and we already know the general solution for this equation, which is x equals n pi plus minus 1 raised to the power n times 7 pi by 6, where n is an integer. So we are ready to move to the next question. So we have question 10 here. Find the general solution